Water is the lifeblood of industrial operations, and ensuring its purity is critical for efficiency, equipment longevity, and compliance. The first step is raw water intake, where water is sourced from rivers, wells, or municipal supplies. The objective here is to bring in water that will be processed for industrial use. Equipment involved includes intake pumps, coarse screens to prevent large debris from entering the system, and pipelines directing the water into the filtration process. At this stage, water may contain sediments, organic matter, and potential chemical contaminants. Next, we move to particulate filtration. This step removes large suspended solids such as sand, silt, and debris. Here we focus on two primary filtration technologies, cartridge filters and bag filters. These filters consist of cylindrical elements that trap contaminants as water flows through them. They are highly effective for removing fine particles and are available in various micron ratings, allowing for precise filtration. Cartridge filters are easy to replace and are ideal for applications requiring high purity. Bag filters use a porous bag made from materials like polypropylene or felt to capture contaminants. Water enters the bag and impurities are trapped within the material while clean water flows out. Bag filters can handle higher flow rates and contaminant loads compared to cartridge filters, making them suitable for pre-filtration applications. However, they may not achieve the same fine filtration levels as cartridge filters and require regular maintenance to prevent clogging. By using the right combination of these filters, industries can achieve effective particulate removal while optimizing operational costs and minimizing downtime. Whether you are a project manager or an operator, you should always ask yourself the best way to determine the right filter technology for your application. So here's a question for you. How do you select the filter technology to be used in your project? In most cases, CapEx determines the decision. However, the cheapest filter in most cases will not provide the best results in the long run. Allowing filter specialists to go over the application with you and study the needs and current scenarios will enable you to make a decision based on the best combined results on the long run. In some cases, water requires chemical pretreatment to adjust its pH, aid in coagulation, or neutralize specific contaminants. His process involves dosing systems that introduce coagulants, pH adjusters, or antiscalants into the water. This ensures that suspended particles aggregate for easier removal and that the water chemistry is optimal for further filtration. Now it's time for disinfection. Depending on the application, water is treated with either chlorine or ozone. Chlorine is a widely used disinfectant, eliminating bacteria and pathogens. However, ozone treatment provides an eco-friendly alternative, effectively destroying microorganisms without leaving residual chemicals in the water. This step ensures that harmful biological contaminants are neutralized before the water moves forward. After disinfection, the water passes through activated carbon filtration. The objective of this step is to remove chlorine, ozone byproducts, and organic contaminants that can affect water taste, odor, and chemical composition. Activated carbon works through a process called adsorption, where contaminants are attracted to and held on the porous surface of the carbon material. Activated carbon has an extensive network of tiny pores that significantly increase its surface area, allowing it to capture a large volume of impurities. The filtration process can use activated carbon in granular form or block form, depending on the required flow rate and application. Granular activated carbon is ideal for high-flow systems due to its loose structure, which allows water to pass through efficiently. However, the loose structure generates fines that should be removed from the water stream. For that, a post-filter should be used to hold the fines and protect systems downstream. Also, a pre-filter is recommended to extend the life of the activated carbon. Block carbon filters, on the other hand, provide more precise filtration as they force water through compressed carbon material, making them highly effective for removing finer particles and volatile organic compounds. When using activated carbon filters, the media should be replaced based on differential pressure. Is that statement true or false? This is false. Activated carbon filters should not build differential pressure, and they should be replaced either based on time or based on an analysis of the water to determine if the carbon is still absorbing the contaminants it is supposed to remove from the water. The main purpose of this step is to protect the reverse osmosis membranes and extend their service life. For this reason, it is recommended to use absolute rated depth cartridges with graded density. These cartridges provide a consistent pore structure, ensuring the effective removal of fine particles before they reach the membranes. By using these high-efficiency filters, the system minimizes fouling and scaling on the RO membranes, ultimately extending their lifespan and reducing operational costs. Absolute rated depth cartridges outperform traditional string wound or bag filters, offering longer service life, better contaminant retention, and superior protection for the reverse osmosis system. Can you tell the difference between an absolute filter and a nominal filter? Visually, both are identical. The difference is in the engineering and production of these two types of filters and in their performance. Nominal filters' performance is anywhere from 60% to 90% removal of particles of a given size, while absolute filters usually are over 99% efficient. Now we reach one of the most crucial steps, reverse osmosis or RO. RO systems use high-pressure pumps to force water through semi-permeable membranes, removing dissolved salts, minerals, and microscopic contaminants. RO membranes operate using crossflow filtration, where a portion of the water passes through the membrane while the rest continues to flow, carrying away rejected contaminants. This design helps prevent clogging and allows continuous operation. These membranes are capable of filtering down to 0.0001 microns, effectively removing bacteria, viruses, heavy metals, and dissolved solids. The efficiency of RO membranes is highly dependent on proper pre-filtration. If inadequate filters are used upstream, the membranes can become fouled with sediments, organic matter, and scale, leading to frequent cleaning and reduced performance. Regenerating fouled membranes requires costly chemical cleaning procedures, while severely damaged membranes may need complete replacement, an expensive process that can disrupt operations and increase long-term costs. High-quality pre-filtration significantly extends membrane life, ensuring consistent water quality and reducing maintenance expenses. Storage and distribution. Finally, the purified water is stored in dedicated tanks before distribution throughout the facility. To maintain water quality and prevent contamination, sterile vent filters are installed at the top of the storage tanks. These filters allow air to enter the tanks as water levels fluctuate while preventing airborne contaminants, bacteria, and particulates from entering. From this point, the treated water will be used for various applications throughout the plant, such as steam generation, production processes, and cooling systems. Additionally, some portions of the water supply may bypass certain treatment steps, depending on the specific requirements of different industrial applications. Last question, how would you rate your current water treatment system? Would you consider it to be A, ideal, running smoothly? B, does what needs to be done but could improve? C, I need help with my current system. And D, what water treatment? Whatever the situation is, count on Clear Choice Filter to keep the system operating at its optimum condition. From raw intake to final storage, every step in industrial water filtration is carefully designed to ensure high efficiency, equipment protection, and regulatory compliance. With the right filtration systems in place, industries can optimize performance while reducing maintenance costs and environmental impact. Interested in improving your water filtration system? Contact Clear Choice Filter today to explore customized solutions for your industry.